Okay, so what we are doing is we are seeing how these various operations can be visualized uh, using this kind of a graphical representation of your complex numbers. Okay, so what we're going to do is vary a and b, uh, c and d, and then see how we are actually getting the various numbers. Okay, so if I vary the real part of z1, that's exactly what I would expect. Yeah, the real part is on the horizontal axis, so the horizontal part should vary. So z1, the tip of z1 should just move parallel to the x-axis, to the horizontal axis. Similarly, if I vary b, it should move up and down. Z1 should move up and down. Okay, I can show the conjugates. Yeah, so I can move that there. Yeah, and show the conjugates there. I can so there conjugates are there. Z1 up there, and the dotted line below, directing below there, is Z1 bar. Similarly, Z2 is down here and its conjugate is up there. Okay, you click that and say show the sum and the difference, and you should be able to see that, yeah, the sum and the difference there. So the sum is the purple line, the pink line is the difference, yeah, Z1 minus Z2. And I can show the product and quotient if I want. Alright, so the green one is Z1 into Z2, and the yellow one is Z1 divided by Z2. Is that okay? So it's pretty straightforward, nothing fancy. Please use the class chat, not the sharing window chat. Yeah. All right. The second one is the powers of the complex numbers. How is the difference greater than the sum? Where is there a greater than or lesser than issue here? I don't know what we're talking about. Where was the difference greater than the sum? Yeah, well, see, the thing is, you are subtracting, right? So whatever you get, you get. Yeah. Please note, with complex numbers, you can't say one complex number is greater than another. Yeah, that is a meaningless thing. Yeah. But you can talk about the slope being greater. Yeah, that's fine. Here you can see that A is around 3, C is around 2. So if I subtract, I'm going to get 1. Yeah, for the real part of Z1 minus Z2. Whereas B and D are 4 and 1 respectively. So the imaginary part would be 3 there. Whereas if I add, A plus C is 5, B plus D is also 5. Yeah. So if I take the ratio of those, you can see that the angle for Z1 minus Z2 needs to be larger than the one for Z1 plus Z2. Yeah. The complex numbers, please note, as I said, there is no what we would call an order relation between complex numbers. I cannot say Z1 is less than Z2 or anything like that. So as soon as you don't have that, then making that sort of a comparison is also not very meaningful. Yeah. So we can't talk about z1 minus z2 being lesser than or greater than or anything like that. Yeah, I have to check that why the value is not being displayed. Yeah, for some reason it was showing it earlier, before now it's not showing. I don't know why. I need to check that. Yeah, I will fix that. Uh, yeah, when you're saying comparing, Sneha, I'm presuming you mean greater than, less than, and all that. The only comparison that is there is equal to. Yeah, so z1 will be equal to z2 if the two real parts are the same and the two imaginary parts are the same. That's the only way of comparing. Yeah, I can't talk about any other kind of comparison. I can talk about real part of z1 being greater than real part of z2. That is fine. I can talk about imaginary part being greater than. That is okay. But together, as a complex number itself, a plus bi and c plus di, I can't put a less than or greater than sign between them. That makes no sense. Okay. So moving on to these powers, what I'm going to do here is just move very n, just to show you how that tip, the point Q, actually moves. Yes, so to show you the locus initially. Yeah, so with n equal to minus 10, you can barely see Q there. Yeah, Q is barely visible. It's down here. Um, 0 comma 0 is the coordinates given. It's not exactly that, but it's very close to that. You can see now, just focus on this point here. That's the point Q. It's going to start moving. Please take a look. N is minus 9. I hope you see it moving. You can see here, for n equal to 0, the complex number raised to the power 0 also gives you 1. And that's exactly what we see here. The value of Q is 1 comma 0. 1 being the real part, 0 being the imaginary part. So in other words, it is the number 1. Yeah. So even complex numbers satisfy that property of x to the power 0 is equal to 1, where x is a not negative number kind of a thing. Yeah. So as we vary n, you can see that this thing keeps rotating around that origin point. Yeah, it will keep doing that. If we had larger values for n, it will keep rotating about the origin, and in this case the magnitude will keep increasing. Yeah, because the magnitude of a plus bi, a here is 1 and b is 2, so the magnitude is root 5. So that magnitude keeps getting multiplied by each other. So you can see here, for example, if I put n equal to 2, if the magnitude of the original complex number is root 5, then the square of that is 5. We should see with n equal to 2 that the magnitude of q is 5. So let's test that. Okay, so there it is. You can see q is the point minus 3 comma 4, and 3 squared plus 4 squared is 25. Take the square root of that, you get 5. Is that okay? Okay, now I'm going to reduce a and b, and I'm going to ask you to kind of predict what's going to happen. Yeah. So suppose I make a somewhere between, yeah. So a is 0.4. I'm going to make b also 0.4. Sorry, less than 1. Yeah, so I'll make b 0.2, let's say. Did you notice something happening? What happened? Describe in your words what has happened. I think you want to talk about it in a different way, Sneha. I think you got the right idea, but that's not how you would describe it, or not how it should be described. Others care to elaborate on this point? The imaginary part of the complex number is reduced. Well, so has the real part, yeah? I made the real part to be zero point 0.4, imaginary part to be zero point 0.2. So that's not an observation. That is part of the data given, yeah? Observation is what you see on the graph. Yes, come on, people. Let me bring B back. Sure, of course I can show you again. Let's say A is whatever, 2.8, B is something. There you go. Okay. So we have that. Now I'm reducing A to 0.4 or so. 0.4, B to 0.2. Locus curve becomes large. That's specifically with respect to the exact numbers that I've chosen. That's it. See, a locus. Please note, as again, locus is a path that is traced. Yeah. So Jacob and Sneha saying that the path is negative. That just not does not sit well, right? I mean, what does that mean? What would you mean by the path is negative? As the numbers become smaller, the locus becomes larger. Again, I don't know what you mean by locus becoming larger. I think even with the B, for example, here, it's quite large, right? Yeah, I think. Yeah, that's right, Sneha. It's the direction that has changed. Yeah. Earlier, yeah, you can see now that this is a counterclockwise locus. Yeah, if you start with O, you as n increases, that arrow is moving counterclockwise. Yeah, and that's the direction of your locus itself. Yeah, so it's moving counterclockwise. If I make B back to 0.2 and I change n, yeah, so you can see the locus itself has become is going in the going in the clockwise direction. Do you see that? Yeah. So the direction of the locus changed. Yeah, and that is an important aspect. You can see here that earlier the magnitude of the complex number was greater than 1. In that case, the locus went counterclockwise. When in this case you have a equal to 0.4, b equal to 0.2, the magnitude is less than 1. In that case, this locus goes clockwise. Let's see what happens with negative parts. Yeah? So a is -2, b, let's say, is still positive. Yeah, let's make it positive 2. Okay, and you can see again the way it changes. Again, it is counterclockwise because the magnitude is greater than 1. Yeah, a being -2, b being 2, the magnitude will be 2 root 2, which is greater than 1. And so still you have a counterclockwise direction. Is that okay? Okay, so now I'm going to stop my screen share, and I will give you values of A, B, C, and D for the first one, and then for the second one A, B, and N. And I want you to tell me what values you're getting. We'll use the regular chat itself, not any fancy chat. Is that okay?